black hole paradox, where quantum mechanics and Einstein's theory of relativity clash. The idea of black holes themselves is quite a fascinating one. Regions of space having an intense gravity from which nothing can escape, not even light. Black holes are one of the most intriguing phenomena in the universe, and they also present one of the biggest problems in physics today. This is because they seem to be the key to understanding the unification of Einstein's theory of general relativity with quantum mechanics, the two pillars of modern physics. Einstein's theory of relativity tells us how space and time, intertwined in a flexible fabric, are affected by mass and energy. It describes how planets orbit stars, how galaxies spin, and how light bends around massive objects, but it falls apart at the singularity inside a black hole. Similarly, quantum mechanics describes the bizarre world of atoms and subatomic particles, where uncertainty and entanglement reign supreme. It works great at small scales, but doesn't account for gravity. So far, we haven't been able to combine these two theories into one coherent picture. And that's where black holes come in. They are the ultimate testing ground for our understanding of the universe. One of the most famous paradoxes related to black holes is the information paradox. Stephen Hawking discovered in 1974 that black holes aren't entirely black. They emit a faint radiation due to quantum effects near their event horizon. This radiation, known as Hawking radiation, has a temperature inversely proportional to the black hole's mass. As a result, black holes aren't eternal. They slowly evaporate over time, losing mass and eventually disappearing completely. This evaporation process poses a puzzle. As the black hole radiates energy, it loses information about the matter that fell into it. This is a problem because quantum mechanics says that information cannot be destroyed. This apparent contradiction between general relativity and quantum mechanics is what we call the black hole information paradox. Another interesting paradox related to black holes is the firewall paradox. The event horizon of a black hole is the boundary beyond which nothing can escape. It's like a one-way membrane separating the inside of the black hole from the outside universe. According to Einstein's theory of general relativity, the only thing that can cross the event horizon is light moving at the speed of light. Nothing can cross the horizon from the inside to the outside, because nothing can travel faster than light. But quantum mechanics suggests that there may be a more complicated reality. Some physicists believe that there could be a kind of wall of fire or a region of extremely high energy at the event horizon, preventing anything from crossing it. This idea is known as the firewall paradox, because it seems to contradict general relativity. If there was a firewall, it would mean that information could not be lost when something falls into a black hole. But if information isn't lost, then it wouldn't make sense for the black hole to evaporate as Hawking suggested. Yet another paradox connected with black holes is the time travel paradox. Black holes warp spacetime so much that they can create closed time-like curves. These are paths in spacetime that loop back on themselves, allowing for the possibility of time travel. However, this creates a paradox, because if time travel were possible, it would violate causality, the idea that cause must come before effect. Imagine someone traveling back in time and killing their own grandfather before their parent was born. This would create a logical inconsistency, because it would mean that the person never existed to travel back in time and kill their grandfather in the first place. There are various ways that physicists have attempted to resolve this paradox, such as by proposing that time travel to the past is actually impossible, or that the laws of physics would somehow prevent it from creating logical inconsistencies. But the issue remains an open question. Let's now discuss some of the possible solutions to these paradoxes. One approach to resolving the black hole information paradox is known as the no-hair theorem. This theorem states that black holes can be completely characterized by just three properties: their mass, electric charge, and angular momentum. It means that whatever falls into a black hole is forever lost and cannot be retrieved. This solution aligns with Einstein's general relativity, but it contradicts quantum mechanics. Another solution to the paradox is the idea that quantum information is stored in the surface area of a black hole's event horizon. This is supported by the holographic principle, which suggests that the information content of a region of space is encoded on its boundary. Resolving the firewall paradox requires considering how quantum effects near the event horizon of a black hole might modify our understanding of the boundary. Some physicists argue that the firewall shouldn't be thought of as a physical barrier, but rather a region of very strong gravitational and quantum fluctuations. This would mean that while nothing can cross the horizon from the inside to the outside, information could still be transmitted outward, avoiding the paradox. Finally, the time travel paradox highlights the limitations of our current understanding of physics. Resolving this paradox may require a new theory that unifies quantum mechanics and general relativity. Until then, the paradoxes of black holes will continue to challenge our understanding of the universe. Black holes are fascinating cosmic entities that have captured the curiosity of humans for centuries. In recent years, they have become an integral part of our daily lives. And that's because black holes play a crucial role in shaping the digital world we inhabit. When we use search engines, social media platforms, or streaming services, we are often met with recommendations tailored to our individual tastes and preferences. These recommendations are made possible by sophisticated algorithms that use black hole concepts like event horizons to categorize and rank information. For example, YouTube's recommendation algorithm uses a black hole analogy to determine which videos are most likely to capture a viewer's attention. Just as nothing can escape the pull of a black hole, YouTube's algorithm keeps viewers engaged by feeding them content they are unlikely to skip or ignore. Similarly, Netflix uses a black hole-inspired algorithm to recommend movies and series based on a user's viewing history and preferences. By analyzing a viewer's past choices, Netflix can predict what they are most likely to watch in the future. And Google's search engine uses a black hole concept to organize and prioritize information on the internet. By understanding how people search for information, Google's algorithm can determine which websites and content are most relevant and useful. In essence, black holes are no longer just a curiosity of the cosmos. They are a powerful metaphor for understanding the digital world we inhabit. By harnessing the power of black holes, we can create more personalized, efficient, and engaging online experiences. Whether we are searching for information, entertainment, or trying to understand the mysteries of the universe itself, black holes are sure to remain an important part of our lives for many years to come. But despite the progress we've made in understanding black holes, there are still many open questions and mysteries that remain. For example, we still don't know what happens to the information that falls into a black hole. Does it get destroyed? Is it preserved in the black hole's interior, or is it encoded on the black hole's surface? This question is known as the black hole information paradox, and it is one of the biggest puzzles in theoretical physics. We also don't know whether time travel to the past is possible. Some physicists believe that it's impossible, while others think it may be possible under certain circumstances. Finally, we still don't fully understand the nature of the singularity at the center of a black hole. What exactly is happening inside the event horizon? What is the singularity, and how does it relate to the quantum foam and the fabric of space-time? These are just some of the many open questions and mysteries that black holes raise. As we continue to explore the depths of space and time, we can be sure that black holes will continue to captivate our imaginations and drive our quest for knowledge. So what do you think? Are there any other paradoxes related to black holes that we didn't mention in this video? And what are your thoughts on the various proposed solutions? Let us know in the comments below. If you enjoyed this video, please leave a like and subscribe so you don't miss out on any of our future content. We love exploring the mysteries of the universe just as much as you do. So join us on our journey through space and time. Until next time, keep looking up and keep asking questions. Who knows what wonders you might discover? Thank you for watching.